Thank you very much. Good afternoon, everyone. My name is Terrence Fernando. I'm the director of the THINKlab. Today, we would like to present our work on 4D simulation for supporting truck renewal program. I'm going to be supported by my colleagues, Michal, Cieciura, and Fady, Farag. So hopefully, if you have time, we would like to give an interactive demonstration as well, if it's possible. This work is supported by Network Rail. I would like to acknowledge especially Roy Hickman and also Amit Messania, who supported and encouraged us to do this particular work. So what I like to do is to initially present the background as well as demonstrate a video showing the key characteristics of this particular program. If you have time, we'll go to interactive demonstration. Before that, I would like to tell you a little bit about the THINKlab. THINKlab is an innovation center. It's a collaboration space where we bring industrialists, academics to undertake complex challenges. So we work with a range of sectors like rail, aerospace, automotive, space exploration, building construction, to local government, and so on. From aerospace, we've done lots of projects around distributed design review meetings. So you connect people from Germany, France, through virtual workspaces to undertake design reviews. So we took one of the case studies as the A380 landing as an example. In space exploration, we've done looking at future Mars missions, so we're creating a virtual Mars and they're teleporting scientists to understand where you're going to land, how to maneuver, row, and so on. So it's very much about interactive virtualization of your project design and also bringing teams together before you go there, how to plan and execute that particular operation. So our main challenge areas is mainly collaborative engineering. So this is where you bring the data into a human-centric space where people can sit around and design around a large scale and also through their computers and so on. We also do city modeling and simulation work where we bring 3D GIS environment, social data, which allows you to then look at the city from different point of views like risks, flood simulation, energy aspect, and so on. So we have very much capacity in terms of 3D rendering technologies. In this particular project, we wanted to apply our knowledge into rail industry, and we took scheduling as an example. This is by engaging with people like Roy and Amit. So by analyzing that particular process, we understand that it's a complex, it involves complex set of engineering activities, and the engineer has to think about this process over time and space. Very complex process. You need to make sure that you are not making any mistakes before you go to the construction site. It's difficult to build a common understanding of the schedule within the team. So maybe one person have a very good understanding. How do you communicate that to other people? And also how do you connect with other disciplines like PWA, OLE, and signaling, and so on. Make sure that you have a common understanding of the project in hand. And also current techniques shows that it's difficult to detect potential clashes over time and space, handling space requirements for handling plants, looking at extrusion zones to make sure that you're not risking the activities and so on. So lots of things need to be considered during the planning stage. And also it has, sometimes the schedule keeps changing, your design might change, your circumstances might change, so the schedule is changing. So how do you make sure that those changes are, again, checked properly before you go to the construction site? So how do you eliminate waste, reduce cost, and delivering efficient programs? So when you look at the current approaches, it's very much based on 2D drawings, try to understand how do you manipulate plants and so on. And sometimes use PowerPoint presentations to really see how the plant is entering, how the plants are being manipulated over time. So it's that during that time, you have lots of limitation in terms of trying to exactly replicate that what's going to happen. So one of the current approach is, so once the schedule is done, so people send it to a third-party company, they create a 4D animation. You can play that 4D animation and make sure that you can brief your teams and so on. But the schedule changes sometimes. It could be even the day before. So the animations become useless. Yeah. So our approach has been thinking about, can we create an interactive environment where you can change the schedule at any time of your planning process. At the same time, that should then reflect on the 4D animation and make sure that there's no any clashes, dependencies are checked, and also any delays in a particular task could be explored and conduct some critical path analysis. So in this approach, we'll try to look at how that particular environment might look like. So here we have, in this environment, we have 3 environments. Here, this is the visual aspect. So this is the site that we bring using 3D GIS data. You have the terrain, aerial photographs. We bring your DGN files, so you put the tracks at the right place. Then you have different, so 2 different extra windows. This is where very much like a schematic diagram of your tracks. This one approaches your time-space planning. Yeah, so this one is your chainage. This is your time. So this is space and time. This allows you to define your task activities, moving, digging, and all the activities that you want to apply. So while you are designing this one, you can straight away, you can see what's going on in the 3D space. So it's about using the time-distance metaphor for specifying tasks. And at the same time, we want to use a concept of a library and concept of a tasks. So the library could be several plans, which has its geometry, its size, and at the same time, you can attach performance data, cost data, and so on. So as you build, you can begin to think about, if you use a high-performance machine, for example, what the impact and so on. So that everything is built into that kind of intelligent object concept. We also have a task library in that environment. So you can use that task to define your activities, sequence of activities. So this is a very simple diagram from the IT point of view. So just to show that it's not just animation, there's a software environment underneath, which take the input from the planner and then manipulate that to give you the right information. So here, initially we use PVA models, but it could easily be extended to OLEs and signaling. So here we can create visual models. It has a logical networks. It has pathfinders to go from when you define the task from A to B. It can take that task activities and simulate that your activities and allows you to create a 3D visual representation. So what I would like to do is to present now using a video initially and then go into a live demonstration. So this has been captured from the computer. So this is a video in this particular case. So idea is you can have an interface like a 3D GIS interface. This is where you have your 3D environment. This is your time distance diagram where you specify your activities. And this is where, when you are defining activities, you initially get all the data. You can enlarge that environment. You have different viewpoints. So you have a god's eye viewpoint to look at from the top-down level, or you can zoom into the particular activities, what's going on. This also allows you to, the activity space, time distance diagram, it's also zoom in and zoom out. And you can, if you want to accelerate, you can drag that time lines to accelerate rather than kind of playing real time. So this also been changed. I know this is a kind of older version. You can increase the speed so that you can speed up the whole activities rather than waiting. So 5 days, you can do that in 5 minutes or whatever. So it's very much interactive systems. Let it run for a while. Okay. So now we're trying to show how you define resources. For example, let's imagine this allows you to define what sort of resources you in. So you go into your library, you say that you will, what sort of resources you would like. You define your diggers or doses or whatever. You define that kind of resources into your to assign for that particular task. And then you can go to your task activities. So from the task, you can define whether it's a move task or it's a digging task or whatever, and then it allows you to define the time, so the place where it's going to enter, where it's going to finish, so the start and end time, end place. So this is using the chain markers. So once you define that, once you define that task, then you can assign the resources that you previously specified. Right? So here you said that you're going to, this is a simple task, you're just moving a train. You can see that once it's defined, it's already there in the 3D environment. So here, when you're dragging it, you can see that that particular activity is taking place. So what's happening is while you are thinking in terms of set of tasks, you can visually see it's happening at the exactly right place or virtual place, how it's going to take place. This allows you to keep adding your tasks so that, again, here you're modifying another task, you're attaching second task. So in this particular case, it will be, I think, let's see, second, right. So you attach the second task. So again, you can see the first, when you finish the first task, now you're going to the second task, which has been specified. As we come down, the second activity is now already taking place. So I think this particular task is removing the track in this particular case. So the good thing about this actually, as you can see, it's user-friendly, so you're thinking in terms of time and space. As you're thinking and specifying your task, visually you can see exactly how these activities are taking place, and then you can attach in the future performance data and the cost data, so you can really see the cost impact as well. So you can look at the clash detection, and also to look at the space requirements, and also if you have a delay in a particular task, it allows you to attach delays and really see what are the consequences of that particular task on the subsequent task. So that's the kind of video. So I would like to invite my colleagues now to give a real-time demonstration